For this question, I would use a linked list internally because it allows efficient insertion and removal without needing to shift elements like an array. For a stack, I would use the head of the linked list as the top of the stack. A stack follows last in, first out, so the most recent items added should be the first item removed. For push, I would insert a new node at the head of the link list. Since I only update the head reference, the time complexity is 0, 1. For pop, I would remove the head node and return its value. Since the top of the stack is already at the head of this is also 0, 1. For get top, I would simply look at the value stored in the head node without removing it. That is 0, 1. For is empty, I would check whether the head is null. That is 0, 1. For a queue, I would use both the head and tail reference of the linked list. A queue follow first in, first out. So the first item added should be the first item removed. For in queue, I would add a new node at the tail of the linked list. Since I keep a tail reference, I do not need to search through the list, so this is 0, 1. For dequeue, I would remove the node at the head of the linked list and return its value. Since the front of the queue is the head of this is 0, 1. For sure, I would keep a separate count variable and increase when I enqueue and dequeue and decrease when I dequeue. That way, returning the size is 0, 1. Without a count variable, I would have to loop through the list, which would be in 0n, so keeping a count is the better design. For is empty, I would check whether the head is null or whether the count is 0. That is 0, 1. Overall, the linked list works well for both stack and queues because it allows the important operation to happen in constant time when we keep correct references.